Hey, just checking to make sure we're up. I think we're up. Welcome to the stream, everyone who's going to be here watching later on YouTube. Welcome. It's going to be the 1,000 subscribers live stream. I'm really happy that we were able to get 1,000 subscribers today. And so I want to work on my Zig Debugger. I haven't worked on it in a long time and want to work on improving. I got to fix this thing real quick here. Should have done that before I started the stream. Just a second here. But yeah, so I've been working, I started working on it just again. I figured out that, or I kind of realized I've been working on this man page generator, but the real reason why I did that was because the Zig docs are pretty slow, but found out that you can just run Zig standard, Zig STD rather, in the command line, and it just hosts the Zig docs for you locally, and it's quite a bit faster. So kind of put that aside for now. Maybe I'll take it up again, but I'd really like to get back into the Zig Debugger because that's something I've been having a lot of fun working with. So I got back into it, and in the past I've been using a lot of stuff from the standard library for parsing dwarf files and elf. But there's a lot that it does, not that it's bad, but I just don't need it. I don't need all the stuff. I don't need to parse everything about an elf file. When I'm working with the dwarf, all I need is to parse the dwarf stuff. And so I've kind of been working on writing a lot of my own things, a lot of my own stuff. So let's hide it over there. Close that. Close that. All we need is this. So close that down right now. If anyone knows a good YouTube terminal chat plugin, I know that Boris Crow's got a good one for Twitch, and maybe one day I'll start getting Twitch set up again. But I want to put my music back on. But since I got all the subscribers on YouTube, I thought I'd just do this on YouTube today. Okay. What was the change I made here? Oh. That's what I need. Okay. So yeah, let's get into this today. You don't need to worry about GPG keys. I'm not going to be doing anything like that. I don't really want to work on the build system today. I want to keep working on elf parsing. And so here I have all my elf parsing code right now. And if I look at what we've got, I can run zig out in elf parser. You can see right now I've got it parsing the headers, the elf documents down to the point where I can now find, that's not what I wanted, the different names of the elf sections. So we got debug pub names, debug lock list, debug lock, debug line string, debug line. And right now, the key parts of the dwarf information are going to be the debug info. Here it is, debug info, and then debug line. Typically, I know a lot of the things I've looked at talk about looking at the debug info, and that's useful when writing your debugger for getting lots of information. But right now, I want to work on setting breakpoints, which maybe I'm putting the cart before the horse. But that's what I've been working on and kind of got, I don't know if stuck on is the right word, but working on. So I want to be able to identify where in the elf file the debug info is, which I have now with the headers, and then be able to read that, not the debug info, the debug line, I believe is what it is. Let's pull up the documents here. So we look at, I think it's chapter 6. Chapter 6. Yeah. Here we are. So chapter 6, content, so the name index. Let's see. Name index. Oh, I'm going down, 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 down. Let's see. Name index. Look up by address. Line number information. There it is. Debug line section. Let's make that a little bigger here. So you got the debug line section. Right there, debug lines. Okay. This is what we want to look at. Let's see, because structure set is a function of the program counter, it's convenient to encode the application instruction set in the debug line section as well. Space were not a consideration. Yeah, I've read this before. I'll talk about that later, but the debug line section is what we really care about. So going back to here. Lots of windows open. Okay. What I'd like to build out is we've got the elf header here. We've got that, don't worry about that. The section headers. And so I think what we need to do now is write a function that'll just parse out. If we look at them here, I've kind of written this by hand, obviously, but where we get an elf file, we read the elf file, and we parse the header. We then parse from the header, we are able to parse all the section headers. And from the section headers is where we are then going to be able to find it. So what I'd like to do is build a thing for our elf representation. Perhaps like this. Let's see. Let's do pub const. Actually, let's just call this elf. Yeah, let's do pub const elf struct. And what we'll want in here is sections. And I'd like that to be a map. So we're going to do this as a standard dot string array hash map, string hash map. I'll do string hash map right now. And the type is going to be a section header. Okay. And then what we'll do is need a function that takes in a file. So pub read, maybe? No, read isn't. Yeah, we'll do read for now. Read file. That's going to be standard.fs.file. Okay. Oh, and it needs to return an elf. And what we can do is kind of copy a lot of this. Oh, it should take, yeah, definitely needs a, call this read file. It should definitely take an allocator. Debug dot, or says standard dot const allocator equals standard dot mem dot, no, yeah, mem dot allocator. And okay. Let's write some things here. Reads in a elf file and builds out mapping for sections within the file. Okay. It's actually going to be an error. Call it an elf parse error. Because if this isn't a valid elf file, then that's not going to be good. So elf headers. Do this. Okay. Debug dot no. So we're gonna take the allocator in. Say header data. Const header data is allocator dot allocate U8. We're gonna allocate how many bytes do we need to allocate. So I think this is something that we can determine automatically. So if I look at the health header document, elf header resides, yeah, elf header, beginning elf file. I think it's got a known size. Look at this. There's nothing variable about it. It starts off with 16 bytes for the identifier, and then half word, word. So was that 16, 16? And then a word, and then U size, U size, U size. So let's count this up here. Let's just look at it here. Maps pretty well to what we have here. We've got, well, it doesn't map that well because there's some data I don't keep track of. So it's going to be, just count this out. Let's see, 16 bytes plus another 2, 4, 8, 16, 32, and then we've got 32 bytes there plus another 16 there. We'll count that up. So 32 plus then a word is going to be sorry, 4 bytes. So 32, 4, 8. This is another 8, so 16, 16 and 16, 32, 64 bytes. Okay. Um, really, we only need 64 bytes to read an elf header. I am pretty sure. Let's try it out. We look at the parse function here. Should map up to that. We do read the first few bytes. Sure, it's got magic. Yeah. Yeah, that sounds about right. Okay. In fact, I think I remember seeing that somewhere. It's saying 64 bytes is how big the biggest is. Oh, not there. Oh. Okay. And we call it, yeah, it's a cache line. That's right. I remember that. Okay. Elf parse error. Header data. And so then what we do is header equals const header equals elf header dot parse header data. Oh yeah, but got to read that data first. So we're going to do a file dot read header data. Turn dot header header and should we get that there? Why is it not giving me an error that I don't have the sections there? Oh, okay. And let's see. Let's see. Where was I? Get so distracted. Oh yeah, I need to read the header in. Now this will, yeah, read error. Look at all these different errors we could get here. Let's see. And not the way we save that. We're gonna generate an error union. Okay. File read there. We'll use while. This so it used to be a read all function that's deprecated now. Deprecate in favor of reader. Oh yeah, let's just open a reader. Duh. Header no. File.reader. And then we'll head it in the header data as the buffer. Okay. And what we want is inits the file and buffer. Okay. So really what we could just do, since we're using the reader now, is use a bigger buffer. If we just use 1000 and 24 bytes per let's see, we're just going to read the file in here right now and defer indicator.free. Okay. Const reader. All right, and then r dot read slice alloc. Buffer provided by allocator. Yeah, read slice all, I think is what we want. Then read slice all. This is the new IO interface. Haven't played around with this a whole lot. Fill buffer with next buffer length bytes from stream advancing seek position. That validates previously returned values from peak if the provided buffer cannot be filled completely. I don't really care if I get to the end of stream, but it shouldn't get to the end of stream. All right, read slice short is what we want. Pretty sure. Read slice short and question is, why do I need two buffers? We don't need this then. We could just do file reader buffer equals 1024 bar undefined file reader buffer, and then we can do const header data. So that's var header data. This is going to be 64 bytes undefined. We should do splat 0. Let's do undefined for now. Uh, 64, technically. IO reader. There we go. I should handle it. Right now I don't care. So let's see. Fix me handle error here if read slice all gets into file. Really shouldn't get that read slice all. Shouldn't even take a size anymore. And go buffer with next buffer bytes from stream advancing seek position. Okay. That makes sense. Okay. I see why we have two buffers now. One's to buffer the reading. One is to buffer header data for that. So we should be able to get header data out. So now let's get section data out. Seek. So what we need to do is seek to. So we seek to the section header table. If we look at what we're doing here, we get the section header offsets. So section header offset equals header dot oh, there we go. Section header off. There was a trick here. Section header offset switch header class. Oh, that's right. I think I use just use there. The reason why this is unreachable, just to add a little safety note. This is unreachable because if I remember right, the parse function parse, yeah, right here. Yep, if the class size isn't 32-bit or 64-bit, we get invalid class size error. So there's no way we'll ever get a class size that is different. In fact, why do we have anything like, let's take a look at Arch class. Oh, because yeah, there is a none. The spec defines a none, but it's invalid. That's right. So that's why we have that. Okay. Parsing will return an error for any other value since we already parsed. There can't be any other value. So that's why we can use unreachable there. Handle error here, freeze slice all gets into file. Oh, yeah. So get the header data, we're gonna get the section offset. So now we need to read the string table offset is something we need too to build out this stuff. So we need the string table offset, const stir table offset. This is the elf stir table offset. Is that a switch? No, you just add. This, I'm taking the section header offset as a usize. Plus the string index plus the section header entity size, or times the section header entity size. So what we're doing is we're offsetting the section header offset, and then the section header string index tells you where in the section header index is the string table, the section header for the string table, or no, where the string table is, right? So then the section header string table header yeah, this is where it gets a bit crazy. Should probably call this the section header string table offset. Let's go back to the notes. Wow, that is, I didn't realize how much that washes me out. Camera being so bright. Let's see. Sections, the string table. To make sure. You know, we're gonna pull this up in here so it doesn't blind me so much. And help section header. So yeah, this member holds the section header tables file offset and byte. So the section header table is the offset, okay? And then the stir index, yeah, this member holds the section header table index. of the entry associated with the section name string table. This member holds the section header table index. Okay, so we have a table section headers, and the index in that shows the name string table. So it's actually not a header, I think. File section header table lets one locate all the file sections. Yes, the section header table is an array of this. That's right. So it does tell you where the section header for the string table is. I look at the code again here, not here, yeah. We're printing out names. So we're getting the section header table offset. We're using that to read, oops, the buffer, and we're getting header class. Yeah, we use that to parse. Parse the section header. And that gives us the string table section header. Then we seek to where the string table offset is. That tells us where in the file. Yep, we are. And then we allocate a size big enough for it. Then we read the whole section header table. And that's the string table. Yeah, that's where we get string table data. Okay. So what we probably want to do, instead of doing a string hash map, make this just a hash map. Well, we'll get there in a second. Section header string table offset. In the section header offset, then we're taking the header's string index, multiplying it by the section header entity size. Okay, that gets us right where we want to be for getting the string table. So then we read the stir table section header, const equals parse equals section parse, and what we want to parse is bytes. We need to read those bytes in first, then we'll parse them. So we need to read the bytes in. Read the bytes in. So what we need to do is get and we know what the size of that should be, right? No, we won't. Yeah, we do. Section header has a set size as well, if I remember right. Let's take a look at the section header. No real difference exists between 32-bit and 64-bit section headers. That's not true. I mean, okay. Yeah, it's not true. They have different size, but let's take a look at this. 32, 64, 128, 64, 64 is another 128. It's 256. Oh, sorry, no, that's bits. 256 bits. So let's do that in bytes. 4, 4, 8, 16. Another 16, so 32 bytes here. And then another 8, 16. So 64 bytes. Once again, another 64 bytes at most. Okay, so then the stir table section header buff equals, is it another 64 bytes? Make that undefined. Const. Nope. Bar. So what we want to read is that, but we need to seek first. So my question is, oh gosh, we do reader like file. Kind of look at the file reader. There it is. Memoizes key information about the file handles such as size, current seek position, error that occurred when trying to seek. Okay. So do I still, the question is when I read, do I seek the file or do I seek at the reader? I think I'd seek to with the file. Oh, no. Seek to. I do it with there. Okay. So I take the reader, I seek to with the reader, and then I use the interface. Which also has a seek to function. Oh. Is the interface still underneath? What? Net turns a reader. And the interface turns, oh, the IO reader. That's what I'm thinking of. I thought the IO reader had a seek function. Well, if not, then I will seek and then read. Let's take a look at how that works. So what we'll do is we need to read bytes in. So we need to seek. So we need to do reader.seek. And where do we need to seek to? We need to seek to the section header, stir table, offset. LSP info. What's up with my LSP? Oops. Found the same thing on line 13. Okay. All right, there we go. 31. const. Okay. Local variables never moved. Yeah, I know. We're getting there. But at least now I get my stuff right. Reader.seek to section header string table offset, and then section header so then we read slice all stir table section header buffer, and try that, and stir table section header buff. And the class is going to be header.class, header.data. Okay, that's the section header. Read the section header table offset. Section header table offset. Not sure if I really need this right now, but we'll get it. I do use it somewhere else. U64. I don't think I need that. Delete this. If we need it, we'll copy it back. Okay, now we need to read the section header. What's the word I'm thinking of? Read the section headers and store them with their names. Oh no, we need to read the section header table. Section header table. Read the section header table. Section header string table. Section header name string table. I think that's what it's called. Stir index. Oh yeah, and we need to check to make sure the stir index isn't an invalid value, because if it is, then we need to read the first. Well, we'll do that in just a second. Make this here. To do if stir section header stir index is greater than, or is it greater than that? Oh, oops. Load it, please. Yeah. What is it? This name is larger than the low reserve. Low reserve. 0x, 0. Then the real value is located in the it's not if it's greater than that. If this is equal to section header number X index, yeah, which is U32 max U32 math dot C. We call it max int 32. Then the real value is located larger than in low reserve, and the value is stored in not U32 max, U16 max. Where is it stored? Then the real indexes section name string table section is held in the sh link member of the initial section header. Section header. Okay. We need to check that. Okay, we'll check that in a second, but let's get the section header table working, and then we'll add the code to check it, make sure it works. Okay. So we got the string table, section header parsing. What is it like? Oh, variables never mutated. Yeah, we'll mutate it, and this one's never used. Don't know why I get doubles there. Allocator hasn't been used yet. We will use it. Do not worry. Do not worry. What was I thinking here for a second? String table, section header parse. Yes. So now we need to read the string table. Const section header string table. Should probably yeah, I need to name these better. String table section header buffer. So we'll call this SH, which is a section header for the string table. So all the section headers can have SH in front of them. Section header string table buffer. Section header string table offset. Maybe I should string table buff. Yeah, no, it needs the section header string table buff. You like that for now, and we'll call this string table header, just to make sure we know that that's what it is. And the string table header, here's where we allocate, because we need alloc. No, this is the header. It's the string table header, but it's the string table for the section header named, which is, this is just for the section. String table be like sh name string table header. String. Man. Then this would be the sh name string table. What's the complaint here? Use of undeclared. Okay. Now we do another seek. Reader.seek to yeah. Section header. Offset adder as you size. Hello, hey, yep, 0.15.1. Sorry, I did not check the chat for a minute here, but yeah, I'm just working on an elf parser. Not for fun. I'm working on a Zig debugger, and to get the debug info, I got to read the elf file, and yeah, while I could use what is already existing in Zig's standard library, I want to do it for fun, and then also only use what I really need to use. So that's why I'm doing the elf parser for. But yeah, it's been fun. But yes, I am using 0.15.1 right now. I don't typically follow the nightly, just because I don't really like having to constantly be changing my code just to follow nightly. I'd rather just do it all at once during releases. Okay. So I hate these names, but yeah. If we look at that, then we read it, and then we're going to read. I mean, should read slice all. There. That gets us the section header name string table. Not sure if that, if that's what I want to call it. Let's take a look at this. Section, yeah. Index is section name. Yeah, the section name string table. That's what they call it. I guess I could call it the section name string table. But really it's the names that are associated with the section headers. So that's what we're going to use. What is the compile error I'm getting right now? Local variable is never mutated. That's because I forget to take a reference to it. Let's see. I probably do the same thing with all these other read yet. And there we go. Feel bad I missed those chats. I'll try to keep chat up here and just we'll do this. Just do this. I can see things a little better. Like formatting it like this. That's what we're gonna do. Even Zig formatter doesn't like it. That's all right. We'll have to just deal with that. This one can. Let's do that. Hey. I have not made a debugger before, so this is a bit of a learning experience for me. But I have read quite a bit of the dwarf specification, and I've played around with. I mean, this is a project I've been working on for a couple months, and I put aside for a while. So I guess you could kind of say I started before, but no, this is be the first debugger I've ever made. So it's a learning experience for me and for fun. All right, so we've got the section headers. That's not the, yeah. Table name. So now if we look at what I was doing here, we just went through each of the section headers and read them. For 0 through header dot section number I, const offset is the section header offset. So we'll just do this header dot shoff as usize times that by plus I times the header, just for completeness and consistency, we'll call it like that. And then we don't need this section header parse and the buffer. So this is where things were off. So we'll need to redo this because I wasn't using the reader then. Now we're gonna seek reader.seek to header.shoffset as usize. So actually we don't need that anymore. Should just be yeah, because we'll just read it. Reader seek to there, and then reader.read. We just do a. I'm gonna sneeze just a second. Sorry about that. So yeah, reader. Where was I? Oh yeah. We'll do a buff because each section header is going to be the same size. You can just, I know they're going to be at least 64. Oh, they're not going to necessarily be. Oh yeah. We don't want to do that. So that worked for just a one-off to just read as much data as we wanted and then parse it. But here, we want to buffer the data in. Trying to think what the best way to do this is going to be. Because here we're going to go through each section header. We know the section header has a certain size. You know, at max is going to be 64. But if it's a 32 byte section header, a different size, and I can't quite read that. If I overread, then Why don't I just use I use the reader just to grab how much I need at a time, maybe? Maybe it's a good function for that. Before I was doing it kind of manually. I just read a whole bunch of data, and I could just do that. Let's just do that for now. Which, by the way, alloc right here. Allocator, and you do error defer. Allocator.free. But John, you said you're learning Zig. I didn't even broach that subject there. How long you been learning some Zig? So yeah, I think we'll do just allocate enough space. Yeah, let's do like called sh buffer. I don't like this, but we'll do it for now. No, I don't like this. But okay. Oh, nice. Ziglings was great. A really good resource. I haven't gone back and done Ziglings for a while. I know that they add exercises every once in a while. Ziglings is good. Let's see, const section header buffer. Do allocator dot alloc. And how much do we want here? We want that many. We don't want I times that. We want header dot schnum times that. Yeah. Okay. Now we need to read that buffer. Reader dot read. Once again, we're going to do r dot read slice all into the section header buffer. That should work. And this is not the string table name, it's the section header name string table. Yeah. Okay. I don't know what that meant. And here I'm just printing it out, but we don't want to print these things out anymore. What we want to do is slice it. I don't even know if we need to slice the name. What we really need is just to, so this is where I was going to get to earlier, is rather than storing as a string hash map, just do the hash map. With the key Let's see, let's look at the different hash maps we have. Maybe an array hash map or an auto hash map. Is that auto hash map? Which already has, yeah, the context provided. Because then I just want to do no, I do need to be a string hash map. I want it to be a string hash map. And here is the reason why, for now at least. I could probably change this so I'm not copying. We're going to just do this. Do this copies. Perhaps we could. Oh. Could avoid this. Don't know if it really matters. I mean, I think it does. We're going to be doing a lot of allocations. Not a whole lot, though. It doesn't copy yet. We want to do name. We'll just copy that here because that's what we want. Except for once again, that string table isn't that. It is section header name name section header name string table. Okay. Then we do is, before we do all this, we make our sections string. Let's see, string standard string hash map of section headers. Const var that equals dot empty. Ooh, I want the unmanaged variant. Empty. Yeah. Okay, sections. Sections. So now we're going to take the sections and we're going to put, and we'll use the allocator. And sections error defer this. That's our error defer dot d'init. Okay. E is going to be the name. And section header is the section header. But we need to dupe that name. I don't think section header put actually dupes the name. Excuse me, got the hiccups. Here's the string context. Yeah, I think I need to choose the name. See, this is where I don't really like copying it. But I want to do a lookup on names. Do I really? I mean, do I even really want to look? Maybe I just want to say, am I doing more work than that? Or is it? I could just check if the name isn't a debug line for now, then we'll just discard it and we'll just start with elf and just get the debug information. Why don't we do that? Instead of keeping sections as a hash map, why don't we just do debug line? And it's a section header. Let me say section what the debug line. And yeah, we just do that. And so then we just say if name standard.mem that equal debug line, then no. Let's do this. Where do we read the header? All the way up here. Okay. Const elf rect. And let's do this header. I don't like that answer either, because what happens if we never get a debug line? Let's just dupe right now. Allocator dupe that. Once again, that's another thing that needs to be duplicated is the section header. Yeah. I don't know if I'm reading that right. If self-put context. It puts it with its context, says get or put context. Yeah, we have to duplicate it because we gotta put it on the heap so that we can store it and refer to it later. That section header. So that's what we got to do. Okay. For sure, it won't break things. It'll just be less. This copies data. Could we at least avoid this with the section names? And I think we could. I think we could. In fact, I've got an idea. Maybe we'll try it out in a second. But what I'd like to do is then do dot sections. I think that will fix us here. So I'm gonna up this buffer to be 40, 96, 498, 1024, 20, 48, 4096 for kilobytes. That should be plenty space for the buffer, just a page. Okay, let's convert this into using all the new, yep. Now we can just do myelf equals myelf equals elf dot import. Oh no. Elf dot read file. And we'll use allocator there. And for sure, I'm leaking a ton of stuff. Here, so elf allocator. And see, defer myelf.dinit. Let's write a dnet function here. Pub fn dinit. And to take an allocator, allocator. Okay, so it needs to take an allocator. And what we really need to do is just do self, take itself, self, pointer to an elf. This is self dot header. Self dot sections. D in it. Okay, let's try that out. First, let's make sure we get things working. Develop operands to binary bitwise expression type. Zig, what's it? No, that's not what I want. Zig. Master there. And let's do error unions. Ah, yes. Merging errors, that's the double bar. There it is, okay. Okay, no field or member function named init and error industry. Yeah, there we to try that. Happens if you don't actually use your code. Function takes one argument. Expect the type IO reader found constant IO reader. This does need vbar, huh? Expected type pointer to elf found constant elf. And then no field name sections. What? Not called sections? Ah, I never changed that. Sections. And this is a string. Section header. Array literal requires address of operator. What is that? Parse. 29. This is just using a try. Seek2 doesn't work. Oh, it's okay. Not oh, access denied, unseekable, and unseekable, unexpected, unseekable. You got seek error. Okay, well, let's do that. Standard dot fs dot file dot reader dot seek error. Another address of, man, I made that mistake a lot. Expected type found out of memory. Expected type. That found a pointer to that. Read slice all. Oh, yep. That's already a pointer. Okay. Okay, let's see. Error, expected type U8, found error out of memory. Did I allocate another thing? I forgot to try it. Okay. Error union is ignored. Read slice all. Really? Member function expected argument 0, found 1. What? Oh, it's a hash map unmanaged. Okay, now let's see. Member function expected 2 arguments, found 1. Dupe. Let's see. Comp time type. Dupe isn't what I want for this. I want this. What I want is copy the section header here. Interesting. Stoop won't work here. Need the section header. Oh, look, it worked. Okay. Hmm. So let's take a look at this. We get the header, and then we get a hash map with size 29, available 22, pointer stability, state unlocked. Interesting. I don't think that this is working correctly. I mean, it looks like it's working correctly. You can see that, this matches 29 section headers, 29 section headers here, available 22. I don't know what that means. Is it because there's duplicate names? Because names do get duplicated, I believe. I could prove that by doing this. Standard.debug.name. I'm gonna do printing, storing section header. Name. Name. So empty string, row data, row data, CST, row data from text, see data, data to debug. 7, 8, 9, 10. 23, 24, 25, 26. I only count 2, 3, 4, 5, 6, 7. Nineteen, 20. Yeah, 29 here. No copies. So why does it say available 22? Maybe I don't know what that means. Let's look at the hash map. Hash map. Number of available slots before a grow is needed. Oh, okay, so that has nothing to do with what I thought I was talking about. Okay, that's fine. Okay, I do want to make sure that this is actually working. So what we're going to do is for key value, right? So we're going to loop over it. What's the hash maps values here? We got a key iterator. That's what we want. iterator. Iter equals var iter equals sections dot iterator. Okay. For a while iter dot next item entry. Key pointer, value pointer, we say. Print standard debug dot print key and we're gonna print, let's see, entry dot key pointer dot there and entry dot value pointer dot that. Should be S. Okay. I don't think that that's right. Debug ranges. Debug ranges. Oh, I'm not doing here too. Well, let's take a look at this first. Well, data looks different. Tab, pro data. Let's take a look at this debug info. Okay. We'll take a look at that by object dump. For the one that gives you, W. Yeah, W, I think is what I want. WO? W, we're gonna do, see, Zig out bin. location section. Displays the contents of the dwarf debug section. So use enables contact. Do not log line. Displays the context debug line section. There it is. Length 213246. That doesn't look correct. That's what I was a little concerned about. Let's take a look some more. I mean, it does have address 64, but it says 0. So we do have 8 address size segments. Selector, minimum instruction length. I mean, this is just interpreting it. I want to know. Read the headers. Object dump view section headers. Headers. Okay, yeah. Aha. Debug lines 00. So I just need to convert these into hex. Debug info. I'm looking at the wrong spot. I'm an idiot. Oh, I'm so stupid. FCFED. Okay, so maybe this is parsing it correctly. It's a little unexpected. So this other one I'm guessing is the size. Oh, I just did that. Oh. 567543. 17 EB37. Yeah, okay. I am convinced that this is correct. Okay, cool. Let's save it. Oh, why did I do that? Well, okay. It is saved. It's about time for me to eat some lunch. But thanks for watching, everyone. Have a great rest of your day. Maybe I'll be able to stream some more later. we'll see. Thanks for watching.